Thanks a lot for inviting me to give ICANN's perspective on IPv4 address depletion. I think all of the speakers will be giving you a presentation that has their own kind of perspective, a lens. So you may be hearing a lot of history from all of us, but each of us are going to bring to it our own perspective from either our own organizations or the fact that we were in different organizations in those historic times, and just want to share where we're going. So doom, gloom, and IP addresses. That seems to be what we hear and what we read about all the time. And I'm sure you all are familiar with ICANN. So the IANA function is the Internet Assigned Numbers Authority. And so our authority, so to speak, our responsibility is not just IP addresses, it's the domain name system and the root management, as well as protocols from the IETF, protocol parameters. So whereas we all are focusing right now on IPv4 depletion in the number aspect, and most of my presentation will focus on that, when I get to the end, I'll talk about how it's not just IPv4 addresses that have to work together, because it's part of a system. And the internet protocols are, a system. So the numbers are just one aspect of it. And whereas we focus of emptying the IPv4 address space, we have to think about the other aspects too. So, good, that works. Bob gave you a very good history, kind of the beginnings. So it was an experiment, IPv4, TCP/IP, and it did become core infrastructure. And the IANA actually started early on. That was a title that the researchers came up with about assigning these addresses. And so the early IPv4 addresses were handed out in 1980, and nobody assumed that they would ever be gone because it was an experiment. So hopefully behind me, you can't see this at all. Unfortunately, the resolution is much better, but what you should be seeing is a map of the world. And on the continent of Asia and Africa and Europe, it's dark gray, which means that in 1985, can you even read the letters? Yeah. There basically was no IPv4 address out there. And on North America, it should look kind of rosy pink and pale beige. That's where IPv4 addresses were being used at that point in time. And then Australia, the continent of Australia, should be a kind of a beige color. And I don't know how to get the color to work better on this. It looks really great on my Mac. So anyway, in the early days, it was all research and academic networks. And this information is all taken from the regional internet registries databases. So what we did is we went in and we looked at, okay, where do they have IPv4 addresses assigned? What is the country code assigned with those IPv4 addresses? And where were they geographically? So this is just based on pulling data out of a database. So maybe this one looks better. Not much, but anyway, in 95, basically we started to have the beginnings of some commercialization. It had been primarily research and academic networks. Now you had people that said, well, I think I can make some money doing this. So they started offering some IPv4 services, and so you had more IPv4 addresses that were being used more globally and for different organizations. So if you could see this, basically most of the concentration of IPv4 was in North America, a little bit in Central America. That's kind of pinkish on my screen. The Brazil part of South America had some IPv4, but almost nothing on the western side of South America. Africa is still pretty dark gray, which means they're not really doing anything except for the southern tip of Africa. Australia's now gotten into the game big time. On this map, if you ever see it online, it'll be kind of rosy in the Asia area. I actually think that's an anomaly of the data, because at that point in time, it was very, very, there were a lot of activity in Hong Kong. And I think that that now shows up as Greater China in the databases. And so it looks like mainland China was very, very engaged in IPv4 in the mid-90s, but I believe that's an anomaly of the data and the fact that Hong Kong was quite engaged. And then Japan was very engaged. They were early on. So since these slides are unreadable, except for the basic colors, I'll try and go through them quickly until I get to the next set. So in 2000, not only did we have ISPs that were making money, like UUNet and PSINet and some others that had come aboard, now the major telecommunications and cable companies got interested. So there was more of a rush, and that's why it was, a pandemic, because it just kept spreading. IPv4 was kind of like a disease. A few people caught it, and then they passed it along to somebody else, and a few more people caught it, and it kept going along. And at this point, ICANN was formed, so the US government management, so to speak, of the IANA and the numbers and the responsibility for the unique identifiers was withdrawn. Basically, they said, okay, it's become a commercial thing. We should have some other entity that can manage this going forward, and that's why ICANN was established. So John Postel, the original IANA, was one of the founding members of ICANN, and so he brought the IANA functions into this nonprofit organization. The other thing that happened, obviously, in this same time frame, just before it, and Bob talked about it, was the standardization of IPv6. So pretty much today, this is 2010, this is what the concentration of V4 addresses look like. As you can see, hopefully you can see, most of the globe is now red, which means that there's a pretty good distribution of IPv4 addresses, with some major exceptions. The northern and western part of South America is still lightly served by IPv4 addresses. Remember, this is concentration and just pure numbers. It really doesn't mean that they have no connectivity. And then Africa and parts of the Middle East are still lightly served. So hopefully, oh geez, I really should have used my Mac. What you should be seeing here is half a globe. And basically, what this is trying to say is that the world has a population of 7 billion people, and there are only about 3.7 billion IPv4 addresses available. So my previous slides were showing you where the IPv4 addresses are concentrated, but if we were to think, just imagine that everyone in the world had a cell phone, and that cell phone had a unique IPv4 address. Only half of those people could have an IP address for their cell phone. There just aren't enough. It's a finite number. And so, the one thing we're sure of, Bob mentioned there are lots of things we didn't know, lots of things that we didn't know would happen. We do know there aren't enough IPv4 addresses for every person on the globe. It's about, half the globe population. So it's going to run out unless something else happens. Well, you can't make finite infinite. It's going to run out. So going back to where we are this year and where we are with the run out, these are the statistics from the IANA at ICANN. And I should let you know that the way it works, it is a hierarchy. So the IANA has the IP address pool. And we allocate based on global policies to the regional internet registries. And there's a registry in Europe called RIPE. There's one in Africa called AFRINIC, one in South America, LACNIC. The one in North America is Aaron, and John Kern's going to speak after me. And then there's one in the Asia-Pacific region called APNIC. So we hold kind of the general pool, the one that's draining quickly, and we allocate based on policies to the various regional registries. So far this year, and you all are familiar with /8s and stuff like that. I don't have to bore you with the math. So starting this year, 14 /8s have been allocated to the various regional registries. 8 of them went to the APNIC region. This is not to be so surprising. If you could have seen the other globe slides, you'd see that they were less served than other parts of the world. with some addressing space. And 2 each have gone to Aaron, Lacknick, and Ripe. So that's what we've allocated from the IANA to the regional registries. Now, when we do that, of course, the regional registries have their own policies, and then they distribute those to companies, universities, individuals, whatever. And I'm sure John will speak to that. So where are we as of today? So we have only 12 unallocated /8s in the IPv4 pool. 7 of those will be allocated under this global policy with the RIRs that I just spoke about. And that basically means that they have a certain set of criteria, and when their address pool, the RIR address pool, reaches a certain point, and they have a certain number of requests in the making, they can request more allocations from the IANA. However, once we've given out those 7 and there's only 5 left, 12 minus 7 equals 5, we will allocate 1 each to each RIR so that basically there won't be a race for the last 5. There'll be somewhat of a fair allocation to each of the regional registries. Everyone's been, trying to predict when this will happen, what day will happen. No one really knows. It's probably going to be in 2011 sometime, whether it's early, late, that's still to be seen. And I would expect that John Kern's going to make some predictions about how long it'll take our RIRs to totally run out of numbers. But as you saw on my half-globe picture, there's only a finite number, and there's not one for every person. So what is the state of the IPv4 pool? Basically, if I were a diver, I would not jump into that pool. It would be a little bit suicidal. There's less than 5% of the total IPv4 space left. That's approximately 200 million unique IPv4 addresses. And, it's going, gone, so that's the doom and gloom part of this. So, however, we do have a bright side, IPv6. And as you noted, it's been rolling out since 1998. And if you kind of compare that to my earlier slides where, you saw there were concentrations of pandemic and people started catching on, IPv6 really hasn't been like a big disease yet. It's more like an opt-in. But now I think that we're getting towards the end of IPv4. You're going to see it more as a pandemic. And some people can't really get their mind around how big IPv6 really is. I mean, how many numbers there really are. So basically, what I've shown you here, I had a half globe. All the unique addresses could fit into just half the population of the world. Basically, a /48 of IPv6 would be worth trillions of worlds. So the population of trillions of worlds would have enough IPv6 addresses. And just in case you wanted to really know what a /48 equals, it's 1.2 septillion. I had to look that up, I'm sorry. I really didn't know what all the zeros. That's 10 to the 24. So pretty much a /48, which is, a lot of IP addresses, allows for a lot of innovation. It allows for a lot of new commercial ideas. And so this is not the doom and gloom story. This is the opportunity. And like Bob said on his earlier slides, we didn't really know what we were doing in the early days with IPv4 or BGP or MPLS, which is more current, or any of those things. Even the web. The things that are happening in those areas were unforeseen. We've got enough addresses, I think, that we can do lots of unforeseen things. So now looking at how IANA has allocated the IPv6, because that's our responsibility, to manage the address space, the unique numbers. So what's been done, in 2006, all of the regional registries received a /12. So if a /48 is, 1.2 septillion, A /12 is really, 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 really big. So they've got lots of address space to play with. And I don't know if you can see this one. Oh, good, that's better, better colors. So basically, this, as of 2010, and looking at the RIR databases, this is how the numbers have been allocated. Now, there's two pie charts. The one that says number of allocations is just kind of raw numbers, like we've allocated to this number of ISPs. The number of /32s allocated is to try and make apples to apples. So in the number of allocations, for instance, some ISPs get bigger allocations than other ISPs. And somebody had gotten a /19, I believe, which is a whole heck of a lot of IPv6 addresses. But if you kind of level set and you look at the other pie charts, /32s, you can see that RIPE, which is the European region, and APNIC are the two largest regionals that are distributing IPv6 addresses to end users, commercial companies, people that would use that and deploy that. So now I've talked about the draining pool, the doom and gloom, and then the bright side that there are a lot of numbers out there. We just have to get ready to use them. A lot of people have been using them, but there are some holes, there's some gaps. And I'm hoping that some of the conversations today will be about the gaps. From an ICANN perspective, and now we go back to the beginning of my presentation, remember we do root zone management as well as IP address allocation and protocol parameters. So root zone management is an area where IPv6 needs support. And it needs support for the whole hierarchy of that root zone management, not just the root, which is managed by ICANN and IANA. So one of the things, if you're a TLD, TLD is top-level domain. So a top-level domain, I'm sure you all know that, you're internet people, but I'll bore you with it anyway. It's, you know, like .com, .org, .us, .gov, stuff like that. So you need IPv6 glue in the TLDs in the root in order to be actually able to have IPv6 connectivity. So basically, the name servers need to be able to resolve the IPv6 addresses. So what, can this map be seen? Ah, good, better colors. So pretty much the orange and red colors mean that there's almost no network diversity through the name servers. So there's only like one route or 0 routes using IPv6 to those name servers in those regions. The green routes mean that you have 4 or more diverse paths using IPv6 to name servers. So you can see if you don't have IPv6 glue records for TLDs in the root, you really can't, you know, you can have distributed your IPv6, but in some parts of the world it's going to fail. So another area is that IPv6 addresses need to be in the root DNS servers themselves, not just the name servers and the resolvers for the TLDs, but in the root. And so in 2008, we did enable, you know, IPv6 in the root. But you know, what you have is you have different root servers across the world. And I can't tell what this map looks like. All those little bubbles that you see floating around the globe up there, those are root servers that are managed by various entities. There's all sorts of different organizations that manage these root servers. ICANN manages L. Other people manage others. So as you can see, there are parts of the world that are less well served by root servers than others. So first of all, your TLDs have to have connectivity with IPv6 for glue records. And you have to be able to get to a root server that supports IPv6. There are many, many more root servers in the world than the ones that are shown here. These are the only ones that are IPv6 capable. And you have the URL on the screen, and I'm assuming the slides will be posted somewhere. So, IPv6 DNS readiness. That's what we have to think about from my perspective. There are many, many other areas that you as network professionals probably should be looking at. But this is one area that I think is that glimmer of light in how you can provide interoperability going forward for all your applications that you want to continue. So on this map, this was one of the ones that was hard to see early on. If I were to superimpose the name servers and the root servers onto this map, we have certain areas that are clearly underserved right now with IPv6. So in Asia, except for Japan and Australia, there's a lack of root server access. And in Asia, except for Japan, they need better diversity to get to the TLD name servers with v6. Okay, most of Africa is underserved in both areas for DNS right now. There are small parts of Africa that are better served than others, but most of the continent itself. Then, surprisingly, most of South America is underserved in the root servers. I'm going to be done in 4 minutes, so I'm good. I'm on time. And sorry about that interruption on time. I only have 10 minutes left. So where was I? South America. It's Western South America is more underserved than, say, the Brazil side of South America. And Central America is spotty. So those parts of the world are areas that really are underserved in some ways in IPv4 if you just look at concentration of IPv4 addresses. And there's a big opportunity there for v6 to enable them to start leveraging the bazillion, trillion, whatever number you want to call it, IPv6 addresses and improve their DNS service for IPv6 so that then they can leverage those new addresses that will be coming available. And I want to thank you for your time and giving me the opportunity to give you my perspective on the doom and gloom and where we can be going with IPv6 and the opportunities that might be out there. Thank you.